So I'm going to review how to build an FP tree and do the conditional pattern bases and all of that from our text example. The original transactions are found on page 250, and the FP example is found on pages 257 to 259. As we noted when we did it with a priori, all of these items were frequent. So we're just ordering them in their order of frequency. And then we look at transaction 100. Transaction 100 is I1, I2, and I5, and we're going to order it as I2, I1, and I5 because we're doing it in the frequent order. And so we build our first part of the tree. We should actually have a little header on top of this, but it's just kind of cluttered up my notes here. You could put a little, the empty set, the header right there. You can do that, but I didn't want to clutter things up over here. The next step is transaction 200. So for transaction 200, it is I2, I4, and that we're going to use it in the correct order of frequency, which is I2, I4. So we see that our first transaction was I2, I1, I5. So if we're going to have I2, I4, we're going to go in another direction, and we'll have I2, I4. Transaction number T300 is I2, I3. So we're going to need yet another branch. I'll just move the I2, I4 over to kind of keep them in numerical order. So I2, I3, so we need yet another branch coming out of I2. Notice, by the way, to check the frequencies here as we're building these. Notice our frequencies. When we started with I2, I1, I5, each one of these had a frequency of 1. Our next transaction, I2, I4, we incremented I2 to be 2, and I4 is 1. The next transaction, I2, I3, we incremented I2 yet again to a 3, and I3 is 1. With our next transaction, I2, I1, I4, so I2 is 3, it's now 4. I1, I2, I1, so I1 now becomes 2. And then I4, we have to branch off in a different direction. And now for the first time, we can see that I need to have a path. I have to start creating a path for my I4s. And then my next transaction, I1, I3, so we have to start a new branch in the main tree here, I1, which I'm going to link to my previous I1 and I3. And we have 2 more transactions to go. I2, I3. So again, we had an I2, I3 already before. We have I2, I3, so I'm just going to increment those. And my next transaction, I1, I3. We already have I1 and I3 over here, so I'm going to increment those from 1 to 2. And that is how we build the FP tree. And we have 2 more transactions to go, and we do them the same way. I2, I1, I3, I5. So again, we do I2, I1, I3, and I5. So we had before I2, I1, so now we have to do an I3 and I5. We have to create a new branch. So that's where this is coming from when we incremented I2 and I1. And our last transaction is I2, I1, I3. So I2 is 7, I1 is 4, and I3 is 2. And you can see that if we were to add up all the different frequencies for a particular item, it would be the same as in our original frequency table. So this is our final tree, which is identical to the one that you'll find on page 258, but this really walks you through step by step exactly how that was generated. To generate the frequent patterns, we begin with our least frequent item, and our least frequent item, if you looked at the original list, was I5. So how do we get to I5? We have only 2 ways of getting to I5, through I2, I1, and through I2, I1, I3. So we say my conditional pattern base is I2, I1, and I can get to 1 I5 that way. I2, I1, I3, and I can get to 1 I5 that way. Let's go and see what this tells us. It means that there's 1 instance of I5 found by traversing I1 and I2, and 1 instance of I5 found by traversing I2, I1, and I3. That's exactly what we just saw a moment ago. If min support is 2, we note that I2 is on a path that leads to 2 I5s, because we have an I2 right over here, and an I2 over here. So we see that I2 will lead me to 1 I5, and I2 will lead me to another I5 in this tree. It means I have 2 I2 I5s. We're assuming a min sup of 2 here. As we said, if min sup is 2. I1 also leads me to 1 I5 over here, and also to 1 I5 if I would traverse that second tree, that second conditional pattern base. So I have 2 I1 I5, so that is a frequent pattern as well. But I see that with I3, I don't have an I3 I5, at least not here. So I can't do I3 I5 from here. I do not have a min support over here. Min support is 2, and I don't have enough frequency for that particular pattern. So my conditional FP tree for I5 is, I got 2 I2s and 2 I1s. And you could do the same thing for I4s and for I3. Notice that for I3, there are two different independent conditional FP trees. One beginning with node I2 and one beginning with node I1. What do I mean by that? In order to get to I3, I can go this route, starting with this kind of route over here, and I can go this route. So I have a whole completely separate tree, and we'll take a look at that in a moment, how we'll represent that with two completely separate sets. So we have one beginning, like I said, with node I2 and one beginning with node I1, but it still generates the frequent patterns correctly. So this is taken from the text table 6.2 on page 259. Let's go and take a look at these. Again, starting with I5, so we saw what our conditional pattern base was, right? We had I2, I1, and we got to 1, I5 that way, and I2, I1, I3, and we got to 1, I5 that way. Our conditional frequent pattern tree is we recognize that we get 1, 2 I5s out of I2 and 1, 2 I5s out of I1. We don't get enough I5s out of I3 to be frequent, and so we generate our frequent patterns. We say, okay, I have 2 I5s out of I2 and 2 I5s out of I1 out of that navigation of that tree. So I2, I5 has a frequency of 2. I1, I5 has a frequency of 2, and in addition, I2, I1 together has a frequency of 1, I5 from this conditional pattern base, and I2, I1 together have a frequency of 1, I5, so you have I2, I1, I5 has a frequency of 2 also from the same conditional pattern base. And you can see how you can generate all of your frequent item sets just from looking at that frequency tree, where you only had to go through that data set one time in order to build that tree. So that is a lot more efficient than a priori. Let's just take a look at I4 for a moment. So what would be my conditional pattern base for I4? I4 exists in two places. Just I2, that'll take me to I4. So I2 will take me to 1 I4. And I2, I1 will take me to 1 I4. So I2 will take me to 1 I4, and I2 and I1 will take me to 1 I4. So altogether, I2 is going to take me to 2 I4s, and I1 doesn't take me to enough to be frequent. So I have a frequent pattern of I2, I4, I've got 2 of them. And you can do that for all of them. You can see how that works. Just notice that for I3, we really show 2 completely separate frequent pattern trees because we're starting at 2 root nodes. So that's how you use the frequent pattern tree. That is how you construct an FP growth tree and how you use it to derive your frequent patterns. Here's a problem from the book using frequent patterns, and we can look at the same problem also using a priori. But here's a problem from the book using frequent patterns. The textbook problem 6.6, and of course your homework problem is going to have different values. So M-O-N-K-E-Y, D-O-N-K-E-Y, so monkey, donkey, make, mucky, and cookie. You only count the O once. So the first thing that we do is we just list all the letters and list their frequency, and then we're going to reorder them in the order of most to least frequent. So K, E, then M-O-Y. And the M-O-Y could be in any order. They're all equally frequent. They all have a frequency of 3. So we look at our first transaction, monkey. We use in this order, K-E-M-O-Y. And then our second transaction, donkey. So again, we use it in the correct order, K-E-O-Y. K-E-O-Y. Notice we don't include D or N because D or N are not in our set of frequent letters. So K-E, we can increment these to 2 each. O-Y. Next transaction was M-A-K-E. We use K-E-M. A didn't make the cut. So K-E-M, and we had already used K-E-M before, so we keep incrementing it. The next transaction was M-U-C-K-Y. We'll use K, M, and Y. U and C were not frequent. And we have to start a new branch over here, K, M, and Y. And notice how we keep connecting our indexes there. Cookie, K, E, and O. And again, it doesn't matter that there are 2 here. We're not asking how many O's there are in total. We're asking in how many transactions does O appear. So K, E, and O already, path K, E, and O already existed. So we increment the counts along that path. And those are our 5 transactions. So we can see our final tree right here. And let's go ahead and build our conditional pattern basis. We start with our least frequent letter, which is Y. How do you get to Y? We can get to Y through K, E, M, O. We can get to 1Y. We can get to Y through K, E, O. We'll get to Y that way. And we can get to Y through KM, so we'll get to Y that way. From all of these, if my min sup is 3, in this example I believe min sup is 3, then only K is going to occur 3 times here. K takes me to 1Y over here, and 1Y and 1Y, so KY is going to be a frequent pattern of 3. And as I mentioned here, you can also see by looking at the tree that K has 3 Y descendants, but E does not, and so that way we're getting the correct frequent patterns here. Conditional base pattern for the next least frequent is O, So we can do KEM, and that takes us to 1 O, and K and E takes us to 2 O's. So we see that K takes us to 3 O's, and E takes us to 3 O's. M only takes us to 1 O, so K and E are both frequent. So KEO is 3. In addition, then KO is 3, and EO is 3. Of course, we know from our a priori rule, first of all, we can see it from here. KO is clearly 3, and EO is 3. And KEO is both 3. But we also know that if KEO is 3, our a priori rule is not suspended just because we're not using the a priori method. Every subset of a frequent pattern has to also be frequent, so we know that. The next one is M and E, and you can see that we do all of these the same way, and it helped us to derive our frequent patterns. Now there's actually one more step to this that the book asks you to do. The book is also asking you to list all the strong association rules, meaning with support S and confidence C. And so they're asking us to where min support is 60% and min confidence is 80%. So you should be able to tell by looking at the conditional pattern bases. We can just go through something very short here. You certainly should be able to tell by looking, for example, at this frequent pattern that KEO occurs 3 out of 5 times. It occurs in 3 out of 5 transactions. That tells you already what your support rule is. That tells you that it is 60% support. And how might you determine the confidence? And I'm going to let you work on how you think you might determine the confidence from this. So you'll take a look at that and see if you can figure that out. Of course, you can always just go back to the original set of transactions and see if you're correct. Okay, that's the end of the FP homework example. There's also an a priori homework example.